All right, this is going to be AP Calculus lesson 4-8. We are talking about spherical related rates. Last time we talked about circular related rates, and tomorrow we're going to talk about triangular related rates. So this is where we are in our unit guide, 4-8. We have one more lesson and we are done with the unit, and then we can go into our self-checks. Again, self-checks. We're not going to be here Friday, and even though that we're not here Friday, we're going to be making up the notes, making up the worksheet, and on top of that, I gave you a self-check to do over the weekend. It's four problems. That means you need to spend 8 minutes doing it. I think you can carve out 8 additional minutes.
So our makeup work is finish our worksheet, watch the video, do another worksheet, and then do a self-check.
Yes.
Can you say into that video the SAT is also this weekend?
Yeah. The SAT is also this weekend.
Oh,
yeah.
Good God.
So good luck, Rosalie, and everyone else that's taking. It's going to be Isabel and Rosalie, right?
Yeah.
Anyone else? All right, good luck. All right, so talking about our lesson, we are differentiating volume and surface area. So I did my best at a freehand sphere, which is on my better side for my drawings. To make them look nice, make sure that you have a perfect circle to start with if you can, and then make a skinny little eyelid shape that actually meets at the top and bottom that do get skinnier progressively. One side dash, one side not, and it looks more or less like a sphere. So, what do our variables mean? Lowercase r is radius. Therefore, lowercase r prime is what?
Radius prime.
Radius prime, but it's the rate. And I can draw this a little bit better. Rate
What?
of radius.
What?
So if my units for radius were in, I don't know, what's a common unit?
Centimeter.
I like it, centimeters. The metric. If my unit is centimeters, then the rate of the radius, r prime, is going to be what?
Centimeters per second.
Centimeters per time, yeah, centimeters per second. We'll assume all of these are per second. All right, so surface area is capital S. That is supposed to be a capital S. So let's say surface area, sticking with centimeters, what is surface area going to be? What are the units for surface area?
Rate of surface area?
Well, not quite S prime. I'm just looking for S. What is the units for
Is
S?
it just centimeters as well? Or is it centimeters squared?
Centimeters or centimeters squared? Yeah, that's a question.
Squared.
Centimeters squared, yeah, that's area.
Area.
So if I'm talking about the S prime, that is going to be what?
Rate of the surface area.
Yeah, rate of surface area. And therefore the units are going to be what?
Centimeters squared per second.
Exactly. Centimeters squared per second. And then capital V, that represents our volume. So sticking with our common units here, what are our units?
Centimeters cubed.
Centimeters cubed. Yep, we're going into the third dimension now. All right. V prime, what is that?
Rate of volume.
Yeah, the rate of the volume.
Yeah, right. Is that miles?
So usually when you see rate of the volume,
That's
it's
the only one
filling
I
up
know.
a water balloon or something like that.
Oh, special.
Rate of volume.
My mom.
And therefore units for V prime are going to be what?
Ew.
Centimeters cubed per time, yep, per second, we'll say. Exactly. So notice something interesting here. On our last notes, we had something
That makes sense.
extra in our first part, but now I'm going to go immediately into an example. What are we missing from the last notes? What should the order be?
Wait.
What the fuck is wrong with Chris?
What did you say?
Language.
Rosalie. Yeah. What?
So in our last notes, we differentiated circumference and area of a circle. Shouldn't we be differentiating volume and surface area and adding those to our notes?
Yeah.
But why am I not doing that?
Because we're not going to. we
Yes.
don't have
Thank you, Carly. Thank you.
We're not going. We don't need to. Who keeps
So that's more of the key. We don't need to. We don't need to memorize volume or surface area of a sphere. They will always give it to us. So in my example, I will give you what the equation is for volume. So here's our example. We'll title it the balloon problem. Oops.
Want me to do this?
All right, the balloon problem.
It's very complicated.
We're gonna write it out?
Yep.
Anybody look so good. So like heaven. So good. So good. I was just like, woo!
Yeah.
Your mom looked at.
That's good. Okay.
She's like, I just do 2 hours. Woo!
Again, thank you to technology.
Wow.
I thought he said
I'm surprised you didn't like insert a photo of a sphere. Like, Mr. Sindel would totally rub that in. Like, my sphere's the best. Like, yeah, that is.
I need to practice my sphere drawing. I'm okay with my handwriting. It's getting pretty good. So the volume of a balloon.
Wait, what's the thing above the volume of the balloon? What does that say?
The balloon problem. I can move the little text there. So the balloon problem. So the volume of a balloon of radius r.
Why do you have such a...
What?
Never mind. No.
Is, and I'll give you the equation here, V equals, maybe I should write this out. I'm going to give myself some room here to write out the equation.
What?
And then I'll come back to this. This is how you properly use technology, I believe. So the equation is V is equal to 4/3 pi r cubed. 4/3 pi r cubed. And then there's my period. Okay, well maybe I should leave that there for now.
The power of technology.
So maybe I should just make a new text box. That way it doesn't ruin that one.
I started
Was this in a very sad mood?
All right, so if the radius is expanding at a rate of, we'll say, 14 inches per minute, at what rate is the volume? Maybe I should make this, I'll make it a little bit bigger. Longer, I should say. At what rate is the volume changing when R is equal to 8 inches? And then I can drag this to make it a little bit long. Oh, I have to go like this. Okay.
Yeah, that one was really good.
So,
Unless you're ready.
do we have this written down yet?
I have
Not yet?
all the way if to if.
All right.
Why won't you let us take notes on our computer?
I don't know any quick way for you to write a sigma on your computer without actually drawing it.
No,
But, like, we
I
could
like
do-
writing these.
Like,
Like, I
it
don't like
helps
the word
me
problems, but
remember.
like, yeah, like equations.
If we all had a tablet, then yes, I would teach you how to take notes on a tablet, and that would be a super useful skill for college. But
Let's
taking
do that.
notes in a notebook is also a super useful skill because it's the cheaper alternative to having a $200 tablet.
we still haven't found the other box.
All right. So let's analyze the problem. Like we did before, like we did yesterday, we need to get our variables out of this. So, what are our variables? I'm probably going to have to write the variables on the next slide. I can just copy and paste, I think. So,
Don't stop.
so we have a formula here, which is nice. We can copy that down after we need it. What does this thing mean? The radius is expanding at a rate of 14 inches per minute. That part right here. Yep, R prime. This part right here corresponds to R prime is equal to, is it positive or negative, first of all? Positive and positive 14. Okay. Now we have our next part. We'll do this in blue.
I'm just glad I got it on my list. But I also feel like it's too
Ah.
much volume time.
Yep, that's volume prime. And what is that going to be equal to?
Positive?
Is it going to be positive? It might be. It probably will be.
Oh, wait. We were trying to find that.
We're trying to find
It
that.
says
Oh, yeah.
expanding, not expanding. I don't know. Is it?
Nice.
Shrinking? Yeah. So V prime is equal to something. And then we also have some other information. We also have this.
Radius equals 8.
Yeah, so that's already in variable form. We can just copy that down. R equals 8. And then we have this equation here that we can also copy. But that's the gist of the question. So let me go ahead and grab all of that and put it into my next slide.
You could just plug and chug.
All right, so
How like big it gets. Yeah, sometimes I get scared because I'm like, is it gonna change like that? And then like you let it go, and then it's just it's like that. It's like so satisfying.
all right, so yep, copied all of that correctly, and we also know our equation for volume. I can write that down here. So our volume is equal to 4/3 pi r cubed, and we know that we're looking for v prime. So what should we do?
You should plug in
Plug in. Plug in
the
what?
derivative.
The derivative?
Yeah, shouldn't you get the derivative of
Oh, take the derivative. Okay,
Take
so
the derivative. I
so
meant take it.
tell me what to write.
In the derivative.
V prime. I'm taking the derivative.
4 times pi r squared and r prime.
R prime. Yeah, perfect. The
You
three.
bring the exponent down?
You do bring the exponent down, and it cancels out with that denominator.
Okay.
Silly goose.
Yep. So Joy skipped that step because she saw ahead.
Made a mistake.
Nice, Joy. Once you guys say that, makes me realize how.
All right, and now let's plug in some things. So we have a v prime that we don't know. This is equal to
Like I don't
4 pi, and then something is going to go there,
times
squared.
8 squared times 14.
Yep, so r is 8, and r prime is 14. Oh gosh, that's going to be some arithmetic.
What?
V prime is equal to, well, 8 squared times 14. I don't know if we can all do 64 times 14 in our heads.
Easily.
Oh yeah?
It's 896.
It looks like your phones are glowing as if you're using a calculator or something.
Really? Because my
Wait, her phone didn't? I had my phone open though. But she
896.
didn't look.
Okay, all of this is 896.
Yep.
So
How
this
did
is
you do that?
4 times 64 times 14 pi. All right. And therefore V prime is equal to, Isabel, what'd you say?
64 times 14 is 896, but times 4 is equal to
896 pi. V prime is equal to,
I knew you were gonna forget it to me.
so this is going to be 900 times 4 minus 16.
Yeah. Well, I don't know.
Okay.
Because like I 4 is the last thing. She's gonna forget.
This is the same thing as
I got 4002, but
4 times 900
I got 40
minus 4 times 4. Because there's a subtracting 4 from the 900. So this is going to be 3600 minus 16. So this is going to be 3,584 pi. Is that right? I guess we should check with our calculator.
3,500. You were right.
We got it? Okay.
But you can't forget your units, Mr. Sindel.
That's right, yeah. So let's go back to the problem. What are our units? V prime.
inches cubed per minute.
Inches cubed per minute, yeah. So inches per minute turns into inches cubed per minute. Perfect. So inches
I do 4 times
cubed per minute.
64.
And we don't get calculators on this.
Nope.
Oh, that.
So you could just do your like old-timey multiplication thing where you like line it up and
You can do the old-timey multiplication. There are a few different tricks that I can teach you guys to speed up your arithmetic, but I think it's probably not worth the time. You should spend most of your time on the calculus concepts. All right, so are we clear on what we're doing for volume equations and surface area? If it asks for surface area, it'll give you an equation for surface area, and you can deal with that. Any information that they give you, and I'll repeat this just like I did yesterday, any information that they give you, you need to use. It's not like the SAT where they give you distracting information. If they give you information, use it somehow. If they give you a surface area prime, that probably means you need to take the derivative of the surface area function that they give you. All right, so with that, does anyone have any questions before we end?
Nope. Can we say goodbye?
You can say goodbye.
bye.